So we'll continue with the next speaker of the day, our sixth speaker, who is Himmelstrup. He is the CEO of Nrenergi, and you are one of the leading companies in establishing gas transportation. It will tell us a bit more about utilization of the CO2 and the biomethane in liquid form. So let's give him a warm applause and bid him welcome to the stage. The floor is yours.
Well, thank you very much. It's a bit of a combination here, so we will be going through the LBG, which is liquefied biogas, and also talking a little about the CO2 that comes out of a biogas plant and what we can do with the CO2. So it's not in general utilization of CO2. I think many people know of that. This is what we typically can use, the CO2 that comes from biomethane production. So Nrenergi, we're a company specialized in green solutions for primarily the heavy transport sector. So we do stations for LBG, for instance, for filling of vehicles. And we are tapping directly into this quite ambitious target that we have to reduce the CO2 by 70% in 2030. And just as the previous speakers have been talking about, we do have an issue, especially in the heavy transport sector, because nothing has really happened in the last many years. And the question is, what are we going to do if we're going to reach these targets? I mean, 2030 is in, 7 years? So we definitely have things to do, but we also have solutions that can help us on the way. This is our circular model at the Nrenergi. I'm sorry, it's like a square, but that's because we are engineers. You see on this slide the different bio-wastes coming into the biogas plant. This is the biogas plant, and we have 3 major streams of, let's say, sources that we can use. One is, of course, the biomethane. That was originally why we did it. We also get some manure out as the remains once we have made the gas process. And actually today the CO2 is becoming more and more interesting, more and more popular to use for different applications. I put here carbon capture is one way to kind of take the CO2, make it liquid, and then get it into existing systems, or maybe deposit it underground or in other areas. We can also mix it with hydrogen made from green electricity. And many politicians, they mention the word PTX. Most of them don't know what it is. We call it power to gas, so we exchange the X with a G. We think that's a very good way to produce even more biomethane by combining hydrogen made from green electricity with CO2 made from green biogas production, and then producing even more biomethane. And then we see 2 ways of using the biomethane. One is the more old-fashioned way in the energy sector for energy, electricity, heat, and in the transportation sector, which is the one I'm concentrating on today. And everything is a circular, sorry again, it's a square model, but let's call it circular, so it, society is benefiting really heavily from this way of introducing the waste as a way to create energy. This is another way of the slide shown by Bio just before. You can see that the biogas production is this line. This is the consumption of natural gas, and this key point in 2028, 2029 is when all the gas in the Danish gas grid is exchanged, or substituted by biomethane. We are actually at around more than 30% right now, and it's increasing at a very rapid speed. So actually the prognosis is that in 2027 we will be at this breaking point even before this curve. So that's quite a story. We're very proud of that in Denmark. I'm also happy to see that the red one is the heavy transport, the transport on land, which is the red one, corresponding to, in this case, about 5,000 trucks in 2030. And you can see for yourself that we are replacing a lot of fossil fuel using the biomethane. to fuel the transportation sector. And as said before, why do we have a problem? Well, the problem is that the transport is actually, in this cake diagram, is taking up a third of the emissions. The farmers are taking up another third. And then what we typically talk about on a day-to-day basis is the installation of houses, saving energy in your private house, converting your gas-fired industry to electricity. That's kind of the boring little piece down here. We're doing a lot down here. Everybody's happy, everybody's talking about it. But what we are forgetting is that that's only 1/3 of the layer cake. So we are committed to doing something in the transport sector, but actually using biomethane, we are actually also helping, let's say, or we are helping each other here. The agricultural sector is supplying a lot of the waste. They're taking the manure. So it's a marriage, more or less made in heaven, between the transportation sector and the agricultural sector. So that was kind of just the background. This is, we jumped straight into hardware. I'm sorry, but I'm an engineer. So this is to the question, how do we get this nice biomethane out into the heavy transportation sector? As I'm talking about liquefied biogas or liquefied biomethane, this is a vessel on a truck, on a semi-trailer, which contains a lot of liquid biomethane. So that's cooled down to around minus 155 degrees. It's a cryo vessel that you see for oxygen, for nitrogen, for helium, for other gases. And here it's implemented with liquefied methane. This is a way to get started. If you want to fuel your trucks, you can buy a Scania truck as example, or a Volvo, or an Iveco truck, which is fueled with LNG tanks instead of diesel. And you can have a thing like this implemented on your local site. You can move it to different sites if you want. And this way you can get up and running fairly quickly. You don't need a lot of infrastructure. You can actually refuel directly from the back end of the truck. And yeah, then you can see the specifications. And you can actually also get started at a, well, I would say a reasonable price. I don't know what you say, but that's a way to get started and start being green with your heavy transport. If you like to have your own equipment installed, you can also make a big stationary system. You've probably seen them. They are quite popular, especially in Germany. They're popping up all over the place right now. So that's a big stationary storage tank, and the pump system and evaporators and whatever is needed is down here. And the arrangement is made more or less like you see it from heavy diesel truck, diesel stations, with refueling lanes so that you can fill the trucks from either side. You can do it in a safe manner, and you can do it quickly. Because, I mean, you would need probably around 10 minutes for a refueling of a big truck like this. And in order not to get too much queuing at the different sites, they can be made with multiple hoses and dispensers like this. So that's another way to get started. It's a little more complex because you need to do it as a stationary installation. But as you can see, you can also get started at a fairly low investment. And with this system, you can refuel a lot of trucks. I mean, 10 minutes per truck, and you can have, in this case, you have 3 places. So that means you would be able to refuel around 15 to 20 trucks an hour. So in principle, there are no limitations except that you have to fill the tank more often if you use a lot of biomethane from this station. And just to show you, I mean, it's liquefied gas. It's a minus 155 degrees, so be careful when you use it. You need to wear gloves, and you need to be sure not to get what you call it, low temperature damages. And that's why you have a very, let's say, intuitive interface. You have to tell which truck you're driving. Most drivers, they know which truck they're driving. You will never get a guy driving a Volvo to say he drives a Scania. So this is like foolproof design. And then you can see what's happening, and you can get a small guidance in your own language on the actual dispenser. Quite heavy duty design made for drivers because this is not an operated station. It'll be the actual driver refueling, but it's safe. It's made for its actual purpose. And it's available. I mean, you can order it today and you can have it in 5 months. Okay, that was it with LBG. We will be moving to CO2. So as I told initially, the CO2 is also produced on the biogas plant. This is another picture of our circular model. So you get, when you produce biogas, you get the main components you get are methane, CH4. It's carbon dioxide, it's CO2. And this is put into an upgrading unit where you separate the CH4. We've been doing that for many years. And the CO2 has actually just been sent to the atmosphere. And that's what we are then starting to collect now, saying we want to use the CO2 from the upgrading unit and utilize it. And what we do is we put a liquefaction plant at the CO2 stream. We need to compress the CO2 coming out of the system. We need to actually polish it to make sure that there's only CO2 and not like H2S, sulfur components, any other components that could be in the gas. We need to remove them, and then we need to cool down the CO2, and it gets liquid at around, as far as I remember, minus 35 degrees, depending on the pressure, and we can contain it in the same kind of cryo vessels as we do the LBG. And then we have, as I said, a very similar vessel, and then we can store it. Actually, for quite some time, you can store it in a tank like this without consumption for more than a month. So you can also export it quite long distances if you want. So that's kind of the process when you look at the biogas plant and how we get from the biogas plant to the storage tank. All equipment that's available, this is technology known for many years. It's quite new that we're implementing them on biogene CO2, but otherwise this part is kind of standard equipment you can get. We can supply it, any other similar supplier can supply it. And these are the areas, probably most of them you know. What is interesting here is this, as I said before, all politicians, they say PTX. Nobody knows what it is. We know what it is. We can use it, power to gas, power to e-fuels. You can make all kinds of things once you have CO2 as the source, and you can mix it with hydrogen made by green electricity. So this is one of the areas we see a huge development coming up right now. And then, of course, you can use it also to increase the output from your greenhouses, from any other sources where CO2 is part of the natural growing process. And this is an example. If you want to buy one of these things and put it on your biogas plant, you would have to invest around 2 million euro for a unit with a capacity of 500 kilos CO2 per hour. And it would look something like this with 2 storage tanks and the container and so on. And you can go even bigger, and you can see there's a big start cost to make a system like this. In this case, you would pay 2.4 million euro and you would get the double capacity. So that's just an example. And again, in this case, you would have to wait about 12 months to get a plant like this, but it's also available, and you would be able to store the CO2 on site, and you can call any gas company that would be willing to buy your CO2, and they can pick it up just as they do from their own plants. So that was more or less it.
Thank you so much. Let's give him a hand. Are there any questions? Yeah, we have the first question over here.
Meine Questions auf deutsche Sprache, Entschuldigung. Zu viele Beispiele gibt es, dass Schlepper kann man tanken mit diesem Gas. Nicht für LKW, für Tanken, für die Schlepper. Verstehen Sie?
Was? Also von
Befüllen, Tanken für Traktoren und landwirtschaftliche Technikum.
Ja, natürlich. Also da gibt es 2 Möglichkeiten. Du kannst komprimiertes Gas benutzen, darüber habe ich nicht erzählt. Das ist die einfache Lösung. Dann musst du einen Kompressor haben und dann kann du eigentlich dieser Gas direkt in Traktor oder Fahrzeug tanken. Mit die LBG, mit die großen Tanken, dann müssen wir diesen Kühlungsprozess haben. Aber dann kriegen wir auch mehr Energie in selben Tank, könnte man sagen. So, wenn du zum Beispiel einen Exportlastwagen von Madrid nach Stockholm fahren willst, dann musst du mit LNG oder LBG fahren, also die untergekühlte. und fahrst du von Kopenhagen nach Aarhus, kannst du mit komprimierten, oder bist du zu Hause auf deiner Landwirtschaft mit Traktor und so, ist komprimiert auch eine Möglichkeit.
Okay, danke.
Any other questions? Otherwise, I have one. I previously worked at the Hydrogen Association, and you also have the hydrogen fuel tanks. And at the beginning of new technologies, there's always, troubles. People don't, know how to handle them as well. And when the grid for new infrastructure isn't that large, well, how is the state of things today regarding fueling biogas? Is it no problems, full service contract?
That's a very,
Where are we today?
We are at a very, very good point. I mean, all of Europe is, penetrated by gas pipelines. And guess what? The gas in those pipelines are exactly the same. We just produce it with green technology. So biomethane can, replace all the natural gas you have in the pipelines in Europe if we produce enough.
Yeah.
And that's the actual big difference to any other technology we're working with. The electricity is a big problem for us because we don't have the infrastructure. It's going to be many, many years before we've built out these big, huge lines for fast recharging. And our point is, in the meantime, let's use what we have. We have the pipelines right under us. We can do it in Denmark. We're at between 30 and 40% of the gas is already green. And we are, as I showed here, we are going for 100% in 5-6 years. So that's a very good way to use it. And if you want to introduce hydrogen into the pipelines, a lot of tests are being done. I would just say, well, that you can do that if you want, and you want to do new stuff. But why don't do it the old-fashioned way? Convert it with power to gas. Remember, power to gas, not X. Use power to gas. Use this model that we have here. The biomethane is it's a good, large, a little bit clumsy molecule. It stays inside the pipeline. Whereas hydrogen, you can see it. It's a small, agile. It's the smallest one we have, actually. It wants out. It burns without a flame. It explodes at very low temperatures compared to methane. So, I mean, why not go with the old-fashioned way, make more methane, use the grid we already have. You can always, convert it back if you don't want to keep it at methane. But it's a very good, let's say, storage molecule. We have known it for many, many years, and it's a way to, let's say, use existing infrastructure and just get going.
I'm thinking a little more about the fuel pumps, very hands-on. People got to learn a new technology and use that. If your petrol or diesel car, if the pump don't work here, then there's another one very close to it. So in regards to service, when there are problems on the pumps and so on, because the impression I get is that we're actually over that level where all of the child sickness problems are done. So is that also your point of view, that the technology is so mature and ready for fueling your trucks and fueling your other heavy-duty equipment, that we are in no trouble land on that?
Yeah, more or less. I mean, I'm an equipment supplier, so yes, I would say yes. But I mean, most of the stations on LBG being built today, they're built for heavy-duty implementation, so they typically have more than one hose, more than one pump. I think you have very high availability, similar to diesel. But of course, you don't have the same network, because we've only just started like 5 years ago or 10 years ago. So you will be having to drive a little further. I mean, it's a luxury you have today. You have a truck diesel in almost any, within 5-10 kilometers of anywhere, you can find a truck diesel. That's not the case yet. And when it comes to compressed gas, it's more or less the same. It's being built out. I think in Germany they have about 1,000 stations. I think in Sweden 500, 600. So definitely they are being built out, and the network is expanding, and also the home refueling, so that you can get your own, like the tank I showed you, you can actually get it. You can order people to come to your site, refuel your vehicles, just like you can with diesel, of course, but that's also a way to go. So I would say the interfaces are fixed, so any vehicle with gas can refuel at any station. The availability, especially if you buy from us, is 100%. So I think it's there, but of course, when you compare it to the fossil alternative, which has been there for 130 years, we're not quite there yet, but we're getting there, and it's not those problems we have anymore. It's more the political framework and those things we haven't really discussed. That's, let's say, constraining the actual growth rate here.
Any last questions from the audience? Yeah.
Thank you for your presentation. I have a question about the CO2 part. So you have drawn here that you can carbon capture it, but you also have a picture that you can liquefy it. So who are your off-takers for the liquefied CO2? And is that, I mean, do they have a problem that is coming from the waste? If you're, for example,
No, on the contrary. At the moment, the off-takers from the liquefied CO2 from the biogas plant are very happy that it's green. So if it's used in industry or for what they call biogene CO2, is very popular because it's circular. So you can use it for dry ice production, for industrial processes, for power to X, for instance, where you move the gas from the biogas plant in liquid phase and introduce it at a power to X or a power to gas plant. When it comes to, we can actually make Coca-Cola quality or high-grade food-grade quality, but we do have some problems with vegans, for instance, because they don't like CO2 produced from pigs. But apart from that, it's not. I mean, there's not really anything from the pig left in the. I mean, it's not like you can taste it. But so that would be, let's say, the first step. The problem is that the production capacity of all the, if you just take the Danish plants, is so huge that you would. I mean, there's not enough demand. We can actually replace all the fossil CO2, I think, with 3 or 4 of the big plants in Denmark. So we definitely need to go for more power to X, for more probably carbon storage offshore. I know there are some EU-funded projects right now where they are looking at how can we get the CO2 from onshore plant production and into the offshore underground caverns. And I'm not sure what that would be like. And probably in the far future you'll have pipelines, so it goes all circular. Something comes up that you can use, and what you don't want goes back. But that's not tomorrow. That's in maybe 50 years.
Thank you so much, Jakob. Let's give